tree diagrams are another method for looking at the same problem. It's a type of graph used to visualize an experiment. Each event is a set of branches or outcomes that are labeled with probabilities or frequencies. So in the example given, we've got tossing a coin. The first toss, you can either get a head or a tail, and each has a 0.5 chance. And then at the end of each, there's an outcome, a head or a tail, but you can also chain events. So you can, after the head or the tail, you can throw a coin again and you get another branch, and the tree expands to the right with binary branches. It's slower than the binomial, but it's easier to understand. So it's useful when we want to visualize and understand a problem in statistics. So for tree diagrams, we can take the MCQ problem we've already solved using the binomial. First of all, we draw a tree. Now, this tree will have 10 layers, so it's quite large. At the end, it's going to be it's going to have 20 different outcome points. It's quite a big tree. The size of the tree is 10. That's 10 layers deep, and we want to find out what's the probability that x is equal to 3. So, how many of those paths along the tree end up with 3 correct answers? And that's going to give you the same answers, but that's the binomial. Now, a 10 deep tree is quite long-winded to draw it manually, so we're going to look at an example which is only 3 deep. What's the probability of getting 2 questions out of 3 correct? We've got more than one terminal branch, so we've got 3 layers deep. We're going to be the answer can be this or that, correct or incorrect, so we're going to be using the addition rule. And there's an assignment where I want you to draw, work out, and compare with the formula answer. So let's just start by looking at that briefly. For a tree diagram, the question is either, for a multiple choice test, the first answer is either true or false. So true is a chance of probability of 0.2 and false is 0.8. So then we go and we build the next question, the second question. Again, we attach 0.2 and 0.8 to each limb. For true and false, I didn't write everything out to save space here. And then for the third question, we get the exact same pairing for every node, and we get 0.2 and 0.8 in each one. And this is the reason we didn't do 10 deep, because this is how much space it takes for a 3 deep answer. We look at the terminal node, then we calculate it out. So see the very top path. So a path is a line all the way from the beginning node to a terminal node. So the top path there goes true, true, true. 3 right answers. 0.2 times 0.2 times 0.2. So the chance of getting 3 right answers, getting everything correct, is 0.08. And that's the only path that has everything correct. If we look at the bottom of the tree, then we get the reverse. If we get everything wrong, the first question wrong, the second question wrong, the third question wrong, there's 0.8 chance of each question being wrong. So it's 0.8 by 0.8 by 0.8 is 0.512. So the probability of getting them all wrong is 0.512. And then all the other nodes in between, there are 1, 2, 3, 4, 5, 6 other terminal nodes, so 6 other outcomes. They will contain a mixture of true and false. So if we were going to ask how many times we get 2 out of 3 wrong, there will be more than one node, and we can add them up to get the answer.